Today we're going to talk about basic C and C++ for programming, but we'll start from basic programming skills. Let's talk about the basic structure of a C programming. So there are a few things you need to know before we start to program in C language. The first thing is that we need to include a preprocessor, which is this one. So the preprocessor defines a lot of things like basic functions. So if you see stdio, it means that it's a standardized I/O functions. The H means that it's a header file. We need to have our program to adopt certain kind of files in our system, in our program. So we need to include some existing files or being developed function in our program so that they can be called anytime we want to use. So after that, we need to define some global variables. So if you want to have a variable that is going to be used by all the functions, you need to define over here instead of other place. So if you are defining the variable over here, the number stored in this variable can be changed by any function. In other words, if you are using different functions in your program, the variables cannot be visible by other functions. For instance, if you name a variable over here, you can change a to any number you want to, but if you want to change your number over here, the system is going to tell you this is an error because the variable declared over here cannot be visible by other functions in other place. So that is something you need to know. So in addition to that, keep in mind there are many things that we need to pay attention to. The first one is when you start a C program, you will need to have a main function, as like what we described last time. So the main function is the start point of the whole program. It will start to declare all the variables, and once those variables has been declared, it will execute the code line by line until it reach to the end. Then it will stop. If you never put a for loop or while loop or some kind of loop within this program, then this is going to end the whole process, and the system, the program will return the control capability back to the operating system. So be sure you will need to do a return 0 or return over here to ensure something you want to respond to the system. If you need to have the system to run forever, then you will need to consider to use a loop a command in your system, which is something we're going to discuss later. Okay, let me change the color of the pen. Okay, so in this side there are two basic functions over here. In this side, there are two basic functions. That is one, printf. Second one, that is a scanf. So those two functions are actually defined in this stdio.h. People has developed those parts. We don't need to worry about how to put a character on the monitor, or how are we going to get the character input by the keyboard. Printf and scanf are in charge of those two important functions, and we don't need to worry about it because they are having been developed by programmers in the past. So this one over here is used to display, and this one over here is used to get the input from the keyboard. So they are here, here, and here. So you might see, okay, there are many other things that we are having in this specific program. So you might have gets. Gets is also some basic function developed in stdio.h. So combine all those basic functions and we can start to do our program. But keep in mind, we start our program in the very beginning. That is a main function. So it will execute everything line by line. And the other thing you need to know is that we actually have two functions over here. This one over here is the main part. This is the main part. Of your program. So everything stored over here is going to be a major part that you're going to execute line by line. However, over here we have another function that defined, which is over here. That is something you also need to pay attention to. This is the function that can be used repeatedly. What does that mean? You might see that I have printf over here and I have printf over here. Those are the functions defined in stdio.h over here. If we start to define our own functions like getH, it will be similar. Once the function is defined and has been coded in the program, then it can be called repeated again. So those are the basic structure we have. You need to have a preprocessor. You need to define your global variables outside the functions, and once that has been done, you need to start a very important function, which is the main function. That would be the starting point of everything you have. So be sure you have all the code you need to have. Within this function. If you need to do some specific jobs, then you define another function. That is not part of the main function because the code over here might be used repeatedly. So that's something we need to. That would be the structure we need to know before we start to program a C program. So the next thing we want to do is, so the basic of a C program. A C program start with what is called preprocessor, just like the include function we see in the previous slide. And the main program start with the keyword main. So each program must have a main function if it's a C. All the coding included in the body of the main program include braces and this one end of a coding for the program. So that is the basic thing you need to know. So let's talk about main function. So when the program begins running, the system calls the function main. So it doesn't matter what you do. When you start a C program, it will start from things over here. You might argue with me, okay, so what about the include header files that like stdio.h? Do we start to include those kind of things in the system? The answer is no, because those are the things is to tell us where we can look up the functions, and those kind of like the addresses where I should go to look up for the functions has been programmed in the system. So the first line the program start is actually this line. So it doesn't matter it's going to be initialized a variable or it's going to be executed certain command. you will start the first line within the main function. So be sure you understand the sequence, because if it doesn't matter what you do, even though you put a function, let's say I put a function over here that is going to be int before, and you say you key in a lot of code over here, blah blah blah, it doesn't matter. You won't start the program won't start from here. Instead, you will start from the main function that's given. So be sure you know the sequence. So it also means that you can put as many functions you want before the main function, but they are not going to be executed. The first line that is going to be executed is the first line within the main function. Keep that in mind. So what is a preprocessor? Preprocessor is a definition of something. So we can use define, we can use include. When we are using include, it means that we are include some certain functions which has been developed before by other programmers, and using those functions can be handy and powerful, because later on when we start to use microprocessor, there are a lot of sensors that's been developed, and we have no idea how to program that in great detail. But programmer in the past has been developed those kind of subroutines for many years, so we don't need to develop everything ourselves. We can just pull out the libraries developed by other people, and we can start to do that the code that we want to do. So for instance, you might use this one. In your Arduino program, it means that I'm going to use ultrasonic sensor, and the vendors or the manufacturers has developed the library and the C code for the users. So in that case, you don't need to do anything. You just need to include the H file with all the files included or installed in the corresponding directory, then will be done. And the other thing is define. So when we are using define, normally we are define it is not a variable. We are replace a number with some name that is easier for us to recognize. For instance, we all know that pi equals to the digits can be infinite, but we don't want to put those numbers in the code in our program, because it can be long and tedious. So when we are having something like this, I would like to use a preprocessor. Define pi equals to this number. So next time when I write a C code in the program, so if I want to calculate the diameter or the circumference of a circle, I would like to say 2 multiplied by pi multiplied by 5. So in this case, I don't need to put 3.141596 in this equation. Instead, I just use pi. But you cannot change the value of pi in your program, because over here the pi is defined as a constant, and this constant is like Newton's law or something in physical laws. You cannot change the number. It's given. We know this number is difficult to remember, so we just give it a name. So when we use this name, we know this is going to be equal to that number. So that is something we're going to do. And if you define your CR over here, it means that we can change that all the time. But when you are using define in your preprocessor, you cannot change the number anymore. That's the difference between a variable and the defined number in the preprocessor part. So let's talk about our first program. So the first program, which is, well, that's trivial because everybody uses hello world to be the first program in any kind of language. So I would suggest you guys to use. I believe all of you have installed code block in your system. So if you can key in this code over here in your compiler IDE and compile it and run it, that will be great. You might notice over here we have 2 header files we include. Those are very common files that we're going to use in our program this semester. One is std.out. It means that it's a standard IO functions being included. So it doesn't matter what you do. This line over here is a must. So you need to use that. And stdlib, it means that it's a standard library. In most of the cases, we also need to have this one as well. Since we are engineering students and we need to use engineering, we need to design program for engineering applications. In many cases, we are using a lot of math equations. So I would also suggest you guys include this one. So that if we want to use sine or cosine, we don't need to write our own code. We can just use that. If you want to find out more functions or how a functions can be called, I would suggest you guys go to this website and take a look what's going on. And if you don't know how to use that, how to put the variables into a specific function, this one over here can be a very good reference source. Okay, let's talk about data types. So data type is a very important part of C language. So when we are defining a number, this one over here means integer. This one over here means floating number. So if you need to have a Matisa part, which means you want to have 3.141596, you cannot use this one. The reason I'm saying that is because when I say it's an integer, then it's an integer. You are not going to have anything smaller than 1. So if you have 1.1 and you want to define you have a number which is 1.1, you want to store that in a variable, you cannot store that into an integer variable. You would always need to save that in the floating type variable. Otherwise, the system is going to tell you you are doing something wrong. One other thing you need to remember is when we talk about 1 byte, that is equals to 8-bit. What does that mean? When we say 1 byte, it is actually a number between 0 and 255. If we talk about 1 bit, it only 0 or 1. Okay? So, with that said, 1 byte, it means that it's a binary number of 8 bits. So, we can have 0, 1, 0, 0, 0, 0, 1, 1. So we have 4 digits for the first part and the second part. So for the first part, this is going to be 0, So in this case, what we're going to have is going to be, this is 1 actually, 64 plus 2 plus 1. This is 64. This is 2, this is 1. So this number over here is going to be 67. So since we have 8 bits, so if you put all one over here is going to be following these rules and get the integer number we have. So when we are having that, it's actually from 0 to positive 255. But that is 1 byte. When we are talking about 1 byte, that's something given. But when we are dealing with something else, for instance, we might have different data types in our system. We have character, we have unsigned integer, we have floating, we have double, and we have bool or boolean. So those kind of things is going to be a little bit different. So when you are dealing with those kind of things, be sure you are knowing what is the range of each variable can go up to, because it depending on how many bytes that we can use for this certain type of variable. Keep in mind, if you are using 32-bit computer, the applicable integer, floating point, floating variable, and double variable, they are having different size. So in this case, when we are using regular C and C++ on the Windows, this is the size we are having for our system. If you are using Arduino, it's going to be different. The data length is going to be a little bit different from what we have in regular Windows system. So you need to know what are the applicable range for the number we can use. If your number is beyond the range over here, the compiler is going to tell you, hey, you do something wrong. So be sure you keep this table handy somewhere you can look it up. So there are one thing, for instance, if you are using outside integer, it starts from 0 to the number we have. So if we are using regular C and C++ on the Windows, it's actually 4 bytes. So it means that when we have 4 bytes, it's actually 1 byte is 8-bit. This is going to be 32 bits. Arduino is a little bit different. It is actually a 16-bit CPU. So the applicable number, integer is going to be different. This one over here, since we have 32 bits, so the biggest number we have is 2 to the power 32 minus 1. This is going to be 2 to the power of 16 minus 1. So those are something you need to know. So in short, let me make a remark over here. The applicable ranges of numbers are different if different CPU or MCU are used. This is because the type of adopted processors can have different. There is a keyword over here, resolution. So I'm talking about 8-bit, 16-bit, 32-bit, or 64-bit. Of course, nowadays we are using 64-bit microprocessor for our desktop computer. But when we are using embedded system like Arduino, it's not 64. Normally, we are talking about 16-bit or even lower. So when you are having different type of a CPU, be sure you look it up for the lengths we can use for the system. Otherwise, it's going to give you a lot of surprise. Okay, so let's talk about another thing. So data types. So we have integer, we have floating point, we have a lot of different kind of things, and we also know, based on the previous slide, we also know that if you want to implement a number, let's say integer, we cannot implement anything infinite, huge. The number is going to be limited. So if your system is greater than certain number, what is going to happen? So let's do an experiment over here. You can try this code in code block, and it will tell you what's going on. So this is actually simple. So this is actually calculating in this number. So if n equals to 2, the result is how much? So we can go back to the previous slide and check whether, let me go back. So if we are using this one under Windows, we know this one is going to be smaller than this number, which means if you want to do the calculation over here, it's applicable. So if you run this code, you should get answer. So, but if n equals to 20, I need to tell you, it's going to be beyond the limitation we see in the previous slide. So in that case, you won't get the number. Instead, you will only get the number with power or scientific reading, since it is beyond the range of the data type adopted. So what does that mean? When we are dealing with a number, if we're talking about this one, can be represented as right? Sorry, this should be 5, right? But we are talking about a computer, so it won't display all the digits over here. Instead, it might tell you something like this. So 5 and 6 is actually ignored. It will still tell you a number, but next time it's going to be calculated based on this number. So the more you calculate, the more errors you're going to include in your calculation. So if you are using wrong data types, it will actually give you wrong answer. So you can try 10, 20, and 30. I believe under Windows only 10 you are going to get the correct answer. If you use 20 and 30 and you try to use integer or floating number, it's not going to work. Another thing that we're going to talk about is the operator. So we have equal, we have plus, we have minus, we have multiply, we have divide, all kind of things. Those are the operators we can use in C and C++. But there are something that can be interesting. So if we can actually use plus plus or minus minus in the system. So it means that it's going to be plus by 1 or plus or minus by 1. If we have plus plus, it means that it's going to be a plus 1. But over here, plus plus a, it means that we're going to display the number of a plus 1, because plus plus is going to be add 1 already before add that back into a. But a plus plus means that we're going to take a first, then after we take a, we add 1 back to it. So it's a little bit confusing, right? So let's talk about one example. So let's do printf and print a to the monitor. So initially we declare a and space by that as 10. When we are having a plus plus over here, it means that we're going to print a first. So the result of this line is going to be 10. Okay, but once this line has been executed, a now becomes how much? 11. So a is actually 11 after this one, but it will display 10 because we print a first, then we add 1 to a. So it is going to be 10 in the beginning, but becomes 11 after. So the printf over here is a little bit different. But over here, it's a little bit different because we plus 1 first. So we do this one, then put it in. So we plus 1 plus a. This is a to this one, and plus 1. So that is 10 and 11. Over here, the result is going to be 11 directly because you add 1 to a first, then display the number. This one over here is you display a first, then you add 1 to it. So when you are having those kind of different operators, you need to be careful and you need to know when the variable has been added for 1 or it has been subtracted by 1. So those are a little bit different. Another thing that you might need to worry about or you need to pay attention to is the logical operators. We have equal sign, we have not equal, we have greater, or we have smaller than those. Those things are important when you are having engineering applications. In particular, if you are dealing with embedded system or microprocessor or a lot of switches, this can be important because we might have a combination of multiple digital inputs, and we combine that as a digital number. So if we can use those kind of operators to determine whether one switch has been turned on or not, it can be useful and it can save us a lot of time because we don't really want to check everything bit by bit. Instead, we want to combine everything as a byte. 1 byte equals to 8 bits. So if we can compare 8 bytes, it means that we can actually take 8 switches simultaneously. So keep in mind, this table over here is handy. Which is widely used to find out logical relationship. Okay. So the next thing we're going to talk about is flow control. So now we know how the basic C program should be set it up, and we know basic operators like plus or minus or divide or multiply, those kind of stuff. And we also know some logical operators. Now we need to know how to control the flow of the C program. So, for instance, if we want to know whether I need to turn on light in a room, the requirement is whether it's daytime or it's nighttime. If it's in the nighttime, certainly we want to turn on light. But if it's daytime, we might want to save power, so will turn the light off. So in this case, we might say, okay, then we can use if. If it's daytime, turn it on. Else, turn it off. Well, no. If it's daytime, turn it off. Otherwise, turn it on. So the keyword in this specific example is if. So if we only have two conditions, then we can just use if and else. If this is 1, then run this one. Else, run the other one. But if you have something else, like you have two switches, and switch 1 is the main power, so if it's turned on, then we need to start to execute something else. But if it's turned off, of course everything is off, so that is going to be major thing. But if your main power has been turned on, and this is a floor light sensor, which is going to determine something else. So when the main power is on, then we check the other sensor in the second step. So in that case, we're going to adopt the structure like this. We do if first, then take the more important switch to be the condition that we need to determine. That is going to be the condition we are going to use. And once this one is done, if it's turned out or what, then run this part first. Otherwise, else, if the second switch is going to play, then if this one is doing something else, then blah 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 blah, doing something else, doing this thing. So that is going to be a program flow you would need to follow. So this is still simple. If you have only one switch, then we use one if. If we have two switches, then we use two if. But in many cases, the world is not that easy. This is one example that you can try to work on this one, and then try to see what is the result. In many cases, it's not that easy because we might have multiple switches. Because let's say we are in a birthday party, and we need to control the color of light bulb. So we might have red, we might have blue, we might have green. So this is going to be cake signal. This is going to be music signal, and this one is go home signal. So each one is going to be in charge of different tasks, but our input is not only on and off or 0 and 1. So if and len might be, if else might be a little bit too easy to do. So if we have multiple choices, then we are not going to use if. Instead, we are going to use switch. So switch is going to be taking a signal, but this signal can have multiple values. So it's kind of like a nested if else statement. So the example is that if we wanna do a comment for students based on their grade, so we do A, B, C, D, and F. Of course, we all know what this means. So if we use switch, then the other one is switch this variable and convert that into another options. So if case is A, then print excellent. Case B, print good. Case C, then it's okay. But case D, if it's F, you must do better than this, right? But if we don't specify, then it means that it hasn't been input in the system, so we print something else. So for a switch flow, you need to have switch. Then we have this one to include everything, and after that you need to have many cases in your system. And once that's done, you need to do something else, which is the default. So if nothing falls into anything, you need to have some kind of default option for the system to respond to the user. So that's the reason we put a default over here. We know what's going on. And once that's done, one other thing you need to be careful is every time within the case part you need to put a break. So we have multiple breaks over here. Why is that? The break means that I'm not going to execute anything below this one. Case is a switch flag, but if it doesn't mean that you're going to terminate the code. Break means that I'm not going to execute anything in the following lines. I'm just jump out from this brace after that. So when you see break, it goes out. That's what it means. So if we don't have a break over here, break over here, break over here, here, and here. If you just run this one, it doesn't matter what you do. Since it's case B, so it's going to start from here. So you're going to print, the output is going to be good. Okay. And you must do better than this. Okay. So it means that without break, it's going to run all the lines over here. But if you put a break over here, those part is not going to be visualized. So that is something that we can control the flow of a program. I'll stop right here. Then we are going to talk about different loops in the next video.